one more example where we are asked to talk about the series. Does it converge or diverge? What is that? Well, it's going to be again an example of the geometric series, and let's see why. First of all, if you're confused with fractions, always try to break it into some kind of easier pieces. So I would break it into 3 over 4 to the n plus 4 to the n over 4 to the n. And that is going to be inside of this big sum. Now, we can check what is happening here. Now it's going to be a sum of 3 to the over 4 to the n plus just 1, because 4 to the n over 4 to the n gives you 1. Now, let's see what is happening piece by piece. Since those are just summations, as you understand, so those are just numbers being added up together, 1 plus 2 plus 3 plus 4 plus 5. Those are fractions though, right? So the first term, for example, when n equals 1 will be 3 over 4 plus 1 plus, then n equals 2 is 3 over 16 plus 1 and so on. Since those are sums, you can break it into two sums. So the first series is from 1 to infinity of 3 over 4 to the n, and the second series from 1 to infinity of just sum of ones. Let's talk about each sum separately. Sum of 3 over 4 to the n is from 1 to infinity. This can be written as 3 and then 1/4 to the n from 1 to infinity. Do you understand what I just did? So 1 to the n over 4 to the n is the same thing as 1/4 to the n. N is the same thing as 1 over 4 to the n. Make sure you are good with exponents and rules of exponents. I have a special video about that. If you want, you can watch. Then this is a geometric series. This is my common ratio r. So I'll write down r is very visual over there, is 1/4. This is my r. Since r is 1/4 and it's less than 1 by absolute value, I can say that this geometric series converges. And we even know it converges to what? It converges to finite sum, which is the first term over 1 minus the common ratio. The first term is not always this number over here, so be careful. You need to find the first term by actually plugging, so that was step 1, step 2, by actually plugging n equals 1 into the series and see what is going to happen. So when I plug n equals 1, the first term becomes 3 over, so that's my a. I'll put it in the red color. A is 3 over 4. So I took this one and plugged it over here, or you can plug it in the second form, it doesn't matter. So my first term actually is 3/4. So that is my a, not just 3. Finally, the last step is to calculate the sum. The sum is a, which is 3/4, all over 1 minus r, which is 1/4, equals. If you're afraid to work with fractions, do the way I understand it. When I see fractions over fractions, I create a common denominator at the bottom. So it's going to be 3/4. 1 minus 1/4 is 4 over 4 minus 1 over 4. That is 3/4. 3/4 over 3/4 is 1. Thus, then, after we find out that the first series converges to 1, we need to go and check what's happening with the second series. Because if you remember, we are working with two series here. One is 3 over 4 to the n, and the other one is sum of ones. The deal is, if one of those blows up to infinity, then all of them blows up to infinity, because that's how the summation works. Infinity plus a number is still infinity. So what's happening with the sum of ones? That's going to be my 2. So we had 1. Now we have 2. 2 is the infinite sum of ones. There's no even counter, as you can see, attached to 1. So it's just 1 plus 1 plus 1 plus 1 plus infinitely many ones. Well, from many points of view, you can see that this series diverges. First of all, infinitely many ones added together definitely doesn't give you any finite number. Second of all, you can see that the limit of a sub n, which is 1, n goes to infinity, limits of 1 is still 1, which is not 0. So this series diverges, you can say, either because it makes sense or it diverges by the divergence test. Divergence test says that at least at infinity a sub n should be 0. That's the minimum requirement in order for series not to blow up. But the limit gives me 1, so no way this series converges. Thus, we kind of wasted our time checking the first series. Well, we did not waste, we practiced. But the answer for the whole series, which was series number 1 plus series number 2, it diverges. Because even though the first series gave me a number 1, diverges. The second series gives you infinity, so everything blows up to infinity. That's how you work with problems like these. Keep working hard and you'll be fast with this. Thank you for watching.